Good afternoon, Cappuccino. Sorry it took me a while to get going today. A lot has been happening around here, lots of things to talk about. But first, let's go ahead and go over the warm-up from Flashback Friday. I ended up with, I think, only 2 people who got it right. Now, what did I do with my list? The 2 people who got the Flashback Friday were Jocelyn and Jaden. Way to go, Jocelyn and Jaden. And so let's go over this one. So we have a composite function that when it equals 0, it has equal roots. What does that mean? Equal roots means that actually it only has one root, and like something like this, okay? It's going to have one x-intercept, right? So whenever you see that word roots, should cue you in that you're going to use the discriminant. So this is going to be a discriminant problem. Okay, so I went ahead and I did the work already, so I'm just going to walk you through this real quick. So if I do the composite function of f of g of x, that means I'm sticking g of x into f of x. So f of x is 3x plus 1, so I'm going to take all of this, ax squared minus x plus 5, and I'm going to put it in right here where the x is. So when I did that, I get 3, and then my parentheses, put in my g of x, ax squared minus x plus 5, close parentheses, and then the plus 1. So there's my composite function, and I know I want it to equal 0. I went ahead and simplified it a little bit. I distributed my 3, and then I combined my like terms, and I came up with this. So now this is where my discriminant is going to come in. Since I want 2 equal roots, that means the discriminant is going to equal 0, because that, in effect, means that there is one x-intercept. So b squared minus 4ac has to equal 0. I took my a, my b, and my c, plugged them into the proper locations, and simplified. Negative 3 squared is 9. 4 times 3a times 16 is 192a. And that's all equal to 0. I moved my 192a to the other side, added it to both sides. Divide both sides by 192. I got 9 over 192, which you can reduce. You can divide. Both of those can be divided by 3. And you get 3 over 64. So the value for A is, find the value of A. Good, that's all I needed to do, is 3 over 64. Okay, so that was Friday's flashback. Now today's, if you take a multiple choice test with 12 questions, well, let's go ahead and start setting this up. So N, my number of trials, is 12. There's 12 questions. They each have A through E choices, so A, B, C, D, E. There's 5 choices. Only one of those is going to be correct. So your probability of getting a correct answer would be 1 out of 5, because there's 5 choices, A, B, C, D, E, but only one of them is correct. So the probability is 1 out of 5. What is the probability that you will get a passing score, 70% or greater? Okay, so we need to know, well, how many questions do we need to get right to get 70% or greater? So the thing that I need to calculate is I need to find 70% or 0.7 of 12. So if I multiply that out, I did this problem somewhere. Can I find where I did it so I don't have to think again so hard? Of course I can't find what I did with it. Ah, terrible. I swear I just had it here, and now I've misplaced it. There it is. Okay, so 0.7 times 12 is 8.4. So I need to get at least 8.4 questions right to pass this quiz. Well, you can't get 0.4 of a multiple choice. So that means I need to get a 9 or higher. So I want to know what's the probability that the problems that I get correct, that I will get 9 or more of them correct. Okay, so we could use our graphing calculator, except that the cumulative function only does the inequality the other way. So if I want to find the probability of getting greater than or more than 9 problems right, if I want to do it on the calculator, there's 2 ways I can do it. I can find the probability of getting 9, 10, 11, and 12 and then add those together. Or I could use the cumulative probability function and subtract it from 1. Okay, so to do the cumulative probability function, I know I'm going to have to subtract it from 1. So 1 minus the cumulative of the stuff up to 9, which would be 8. So is less than or equal to 8. Okay, so I can set it up this way. So now I can go to my graphing calculator, and I'm going to do second distribute, go down to not A, but B. There's the cumulative ones, is on B. And I'll select that. Number of trials is 12. Look, I already did it. It's already in here. My probability is 0.2, or I could have put in 1/5. 1/5 is the same as 0.2. The X value is 8. And then I hit enter a few times to get my answer. And I get this insane thing that looks like it's basically 1, right? But we don't round off until we're done with the problem. So I'm going to keep all that in my calculator, and I'm going to do 1 minus that. So I'm going to select that in my calculator, hit enter, and enter again, and it gives me my answer. So the probability of getting a passing grade on this is 6.22, 3 significant figures, times 10 to the negative 5. Okay, so if you're not familiar with this yet, this e negative 5, that means that it's scientific notation, and so this is saying it's 10 to the negative 5. So this was the answer that I was looking for, and I got a bunch of people who got this one right today. So shout out to Izzy was the first person, then Kylie, Sarah, and Oscar. Congratulations on getting that right. Okay, so now on to today's notes. We are still talking about binomial distribution. And now there's a couple more things we can do with binomial distribution. We can talk about mean, standard deviation, and variance. So of a binomial distribution. So first of all, the mean is actually really, really super easy. So we're going to talk about the problem that we just had. So from our warm-up, we had 12 multiple choice questions with answers A through E. And so we would have a probability of guessing the correct answer 1 out of 5 times. Because we have a 1 out of 5 chance of getting any given question right. So 1 out of 5 questions we should expect to get right. Okay, so how many questions would we expect to get correct out of 12 questions? This is another way of talking about expected value, and for a binomial distribution, we call this the mean. The expected value is the same thing as the mean. So right here where it says mean, a couple ways I can talk about this. It can also be called expected value. Okay, and we've looked at expected value before, and or expected outcome. So expected value or outcome, or we've seen this symbol before, or we can just say E of X. That is the mean. That is the average. That is what you would normally expect. What do you think would happen? Okay, so the example from our warm-up that we're going to look at, so we have multiple choice, 12 multiple choice questions, 12 multiple choice questions. With answers A through E. Okay, so we would have a probability of getting each question right. The probability of guessing correctly would be 1 out of 5. Or 0.2. Because A, B, C, D, E, there's 5 choices for answers, only one of them is right. So we have a 1 out of 5 chance of getting any given question right. So another way of thinking about that is for every 5 questions we answer, we should expect to get one of them correct. So how many questions would we expect to get correct out of 12 questions? Okay, given this probability, how many questions would we expect to get correct out of 12 questions? How many questions would we expect to get correct out of 12 questions? Okay, well, kind of easy. We would expect to get 1 out of every 5 correct, so we would do 1/5 of 12. Okay, so we would do 1/5 times 12. We would expect to get 1 out of every 5 of those 12. 1 out of 5 of 12. So we multiply that out, we get 12 over 5, which is equal to, if we change that to decimal, 2.4. We would expect to get 2.4 problems correct. Okay, so if we were just guessing, we had 12, and we're just guessing, that's all we're doing, just randomly guessing, we should expect to get 2.4 of those problems correct. That's why our probability was so low on that warm-up question about getting a passing score, because on average, you should only be getting about 2.4 problems correct. So the chance of you actually getting 9 of them correct so that you could get a C is like really, really small chance of that happening. Okay, so this is what we expect. This is the expected outcome. We would expect to get 2.4 problems correct. So we can call that the expected outcome, we can call it the expected value, or we can call it the mean. Okay, a bunch of different things we can call this. So we're going to write this down. How did we just do that? The mean of x, which was getting correct problems, is in notation, it's e of x, or it's also, we use this symbol. Is that mu again? No, I don't remember. Shoot, do I need to give out more extra credit for telling me how to say my Greek letters? I'll just look it up myself. Okay, so the expected value is just, all you got to do is do the number of trials times the probability of success. It's that easy, okay? Like we just did there. That's what you're going to be practicing on your homework tonight. Super simple. So this is the mean outcome, okay? This is the symbol for mean of a binomial distribution, okay? So the mean. And how did we get it? We did n, which is the number of trials, and we multiply it by the probability of success of something happening, right? Probability of success of that thing happening that you want, okay? We call it success, but I mean, it could be a bad thing. It doesn't imply that it's something great. It's just that's what we're looking to have happen. Okay, so if we can find the mean, shouldn't we also be able to find some other statistical information? And yes, if we can find the mean, things that are associated with the mean are standard deviation and variance. Okay, so we can also find the standard deviation. So what's the typical spread of the probabilities, and the variance, which is just standard deviation squared. Okay, so to find standard deviation, we are going to say standard deviation. Let's write it out. It uses the same symbol, but for a binomial distribution, we actually have a nice little formula that we're going to use. Okay? If you have a binomial distribution, you can use this formula. Okay, the number of trials times the probability times 1 minus the probability. Okay, and we're not going to worry about proving this formula for this course. We just need to be able to use it, and just like and be able to do it on your calculator, right? We talked about, when we learned about standard deviation before, we talked about MAD, mean average deviation. Wait, what was that? Mean absolute deviation. Sorry, I'm saying the letters wrong. We are just going to do standard deviation. We're not going to ramp up to it. And then variance is standard deviation squared. It doesn't even get its own symbol. Poor variance. So not respected. That's just NP times 1 minus P. So super simple calculations today for what we're doing. All right, so let's do a quick example. So like you're going to have in math space. So here's our example. We're going to roll a die. A die is rolled 12 times. Why do I have 12 again? 12 times. It seems to be my favorite number today. And X is the number of sixes that could result. Find the mean and standard deviation. Of the X distribution. Okay, what is X? X is the number of sixes. Okay, it's getting a 6. We either get a 6 or we don't get a 6. So our X is getting a 6. So N, how many trials do we have? So if we're solving this, we would write down our number of trials is 12. Our probability is equal to 1/6. How do we get the mean? The mean is equal to N times P. Sorry, that was messy. Is equal to N times P. So 12 trials, the probability is 1/6. That just equals 2. 12 divided by 6 is 2. Bam, that easy. Okay, standard deviation. Just let's write down the formula. It's N times P times 1 minus P. So that would be 12. Oh, why is the probability, I knew I should talk a little bit. Why is the probability 1 out of 6? How many 6s are on a die? 1. How many sides does the die have? 6. Okay, so the probability of the event happening is 1 out of 6. Okay, so back to what I was doing. So 12 times the probability is 1/6 times 1 minus the probability. Okay, so we're going to simplify that. So standard deviation is equal to 12 times 1/6. We already said that was 2. 1 minus 1/6, well, that would be 5/6. Simplify that. We get the square root of 10 over 6. And I can reduce that. I can divide both the 10 and the 6 by 2. And I get the square root of 5 over 3. If we're in math space and it asks us to round that off to a certain place, then we would obviously use our graphing calculator. So I want the square root of 5 divided by 3, and I get 1.29. So approximately equal to 1.29 is the standard deviation. So my expected outcome is 2. So if I roll a die 12 times, I would expect to get a 6 twice. Okay, that seems to make sense. There's 6 sides. I'm rolling 12 times. You would think each side would come up twice. But that doesn't guarantee that that's going to happen. It says here the standard deviation is 1.29. So that means that on average I'm going to have up to 3 or down to 1, between 1 and 3 are going to come up most frequently. Okay, and we're going to talk about normal distribution starting tomorrow, because this whole thing about standard deviation makes more sense if we start talking about normal distributions and what does that mean for you and life in general. Okay, so for those of you who did not read today's bulletin that was sent out by Miss Mahoney, there was a letter attached from Miss Lopez that you all really, really need to read. Okay, there was a big bombshell in the IB world that came down today, and you really need to go read that letter. Okay, the letter has some really super important information in it about the IB testing in the age of coronavirus. So I will address that more in an upcoming video, but for the meantime, go read the daily announcements from Miss Mahoney and open up the letter from Miss Lopez. All right, see you soon. Bye-bye.